Welcome back, everybody. Our topic today is box and whisker plots. We're still working around our data cycle. For the last few lessons, we've been in number 4 in summarize and analyze. And within this topic, we've talked about measures of central tendency, mean, median, mode. We talked about measures of position, quartiles, and percentiles. And today we're actually going to use those quartiles to do something a little bit different. We're going to write a 5-number summary, but more importantly, we're going to represent that summary graphically using what we call a box and whisker plot. So this is a new kind of chart that you're really going to love because it's super easy. Here's a data set that you've seen before. In our quartiles lesson, I actually had this as example 2, and you might remember it as the one where I had these hands that were moving progressively inwards to find the median. In this example, we're going to determine the 5-number summary, and then we're going to draw a box and whisker plot. Now, just like with pretty much all of our other examples, our first step is to put the data into ascending order. Once we do that, the 5-number summary is just the minimum, maximum, quartile 1, 2, and 3. Those are the 5 numbers, and all we do is list them. So, to answer number A, the 5-number summary, our minimum value is 1, the lowest value. The highest value, or the maximum, is 9. And then in a previous lesson, we've worked out all the different quartiles. Quartile 2 was 4,5, 1, and our upper quartile was 7. So there they are. And that's the 5-number summary. Very quick and easy. The more interesting thing that we need to do with this now is to draw a box and whisker plot. The first step in drawing a box and whisker plot is to use our ruler to draw a number line. Now this is one of the places where most of our students mess up. So you're not going to do this year, you're going to do it properly. Use your ruler and space out the intervals properly using that ruler. So you don't have to count by 1s, you could count by 2s or 5s or 10s or whatever interval you want, but it has to be drawn accurately. You can't just freehand it. Once you've got your number line, you're going to start by drawing in your min and your max values. These are going to be dots. So the minimum value is 1, the maximum value is 9. Then we're going to draw a box from quartile 1 to quartile 3. So quartile 1 was at 2,5. So I've done my best to draw, get my laser pointer here. I've done my best to draw this box from 2,5, which is quartile 1, up to 7, which I can do a little bit more accurately at quartile 3. I then draw a line in the middle that represents the median, quartile 2, which is at 4,5. And then 2 whiskers from the box, so there's my box and 2 whiskers. And then I need to just label each of these pieces with their actual values. So the minimum was 1, quartile 1, 2,5, quartile 2, 4,5, 7, and 9. The reason why we do these labels, even though they're on the number line, is that it needs to be very, very obvious that this is at 4,5. And it needs to be very, very obvious that this is at 7, because often we're going to give the marks based on accuracy for each of these values. So please label them. Now that we've drawn our first box and whisker plot, let's talk about what a box and whisker plot is and what it's useful for. It's a useful way to visualize the 5-number summary. So I can see straight away where my minimum and maximum values and each quartile are. And I can also see how the data is distributed. We often use it to compare different data sets, and we'll see an example of this just now. So let's take away my number line, and I've also taken away the numbers, so now we can just see in general what a box and whisker plot is showing us. Again, we have the box in the middle that spans from quartile 1 to quartile 3, and then there are typically 2 whiskers on either side. But in the next example, we'll see something that looks a little bit unusual. Remember that quartile 1 is where 25% of the data lies below. So our box and whisker plot shows that as well. 25% of the data then lies between quartile 1 and quartile 2, and on and on. So this is a visual representation of splitting the data into 25% intervals or into quarters. Our next example is also a data set that we've seen before. In our quartiles lesson, this was example 1, so I've swapped the order of these two. You'll see why in a second. Again, we put them into ascending order and work out our 5-number summary. Minimum, maximum, and the 3 quartiles. So I'm rushing through that because we've done those in a previous video. Now to draw the box and whisker, draw your number line. Again, your number line properly done with a ruler and intervals spaced out appropriately. You're then going to start with your minimum and maximum values. Draw a box between quartile 1 and quartile 3. The median gets a line, and then you're going to finish off with the whiskers. Now notice that there's one whisker that can't be drawn because the minimum is the same as quartile 1, and that's okay. So this one is just a little bit unusual, but nothing wrong with it. And then don't forget to label all of your values. Now back to our Vitamania example that we've been following through for the last few lessons. Let's draw a box and whisker plot for this data. Here's our stem and leaf plot that we've been working with, and we know that this stem and leaf plot automatically has the data in ascending order. In a previous lesson, we found the quartiles. There they are. And even though this question's only asked for the box and whisker, I still like to write down my 5-number summary. It just makes it a little bit easier so I don't have to actually look at the data anymore. I just have to look at that summary to draw my box and whisker. Now, I need to figure out, because this is a slightly more complicated example, I need to figure out where to start and stop my number line. My minimum value is 11 and the maximum is 87. I like to give myself a little bit of space on either end. So I'm going to go from 0 to 100. And I've chosen intervals of 10, but in this case, I think intervals of 5 could be appropriate too. It just depends what level of detail you want to show. All right, so let's show our minimum, maximum. Draw a box from quartile 1 to quartile 3. The median gets a line, and everything is labeled, and I use my ruler to draw my whiskers. So now that you know how to draw a box and whisker plot, we need to see how they're useful, so we need to do some analysis. To do this, I'm going to compare 2 data sets, but you'll see that they're related. The first one are term 1 marks for some grade 10 class at some school. Let's not name that school, but this is the 10.2 class. So we can see that the minimum value on term 1 marks, the minimum mark was a 46, the maximum was a 79. So no one in this class achieved an A in term 1. We can see that the median mark was 66,5, and we can see our quartiles. So to put this into perspective, 25% of the class got between 46 and 59 for term 1. 25 got between 59 and 66.5, 25% were in this interval, and 25% got in the B range. Now let's compare that to 10.1. 10.1 had a minimum value, minimum mark of 59, a median of 75, so the median mark was a B, a maximum of 93. If we look at this, the bottom 25% were in the sort of I suppose that's a C mostly, and on and on. So I think you get where I'm going here. Okay, and then the top 25% got A's. Right. So now we can use these box and whisker plots plotted side by side to compare the two classes. And there's a lot of different comparisons that we can do. Some of them relate to range, which we haven't talked about yet, but we'll do in the next lesson. But just straight away, I can see that the minimum value in 10.1 was the same as quartile 1, or the lower quartile, in 10.2. So that's sort of interesting, and is that 25% of 10.2 were below the lowest mark in 10.1. Similarly, the highest mark in 10.2 was 79, and that sort of fell within this interval in 10.1. So there were quite a few learners in 10.1 who achieved higher than that. So again, there's a lot more that we could deconstruct out of this. But I think if you were someone in 10.2 who wanted to move up next year to the top set, you could use an analysis like this to try and see where your marks need to be. To me, this sort of is a normal distribution for a top set and a second set, so there's nothing to worry about here in my opinion. To me, this shows that the sets are quite well appointed, meaning that the right people are in 10.1 and the right people are in 10.2. Maybe you guys can prove me wrong.